Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Most students look at sequences and series and see a comforting menu of predictable formulas. Need an arithmetic sum? Use the standard summation equation. Dealing with a geometric decay? Apply the geometric sequence formula. It's clean, structured, and entirely formulaic. High-tier math competitions and advanced exams like the Putnam, the AMC, or IB higher level papers don't play by these rules. They aren't going to hand you a neat common difference or an obvious multiplier. Instead, they will hand you variables trapped inside transcendental logarithms, or systems where arithmetic and geometric progressions morph into one another mid-problem. They want to see if you can handle structural chaos. To survive advanced exams and contest problems, you have to stop thinking like a calculator and start thinking like an architect. Today, we're mastering the advanced structural mechanisms needed to crack those boss-level puzzles. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on your weekly content. Take a moment to read this problem if you haven't had the chance yet. And once you're ready, we're going to jump right in. We know that the area of frame 1, we're going to call that A sub 1. That is going to be equal to 4 times 5. So the area of F1 is 20 centimeters squared. Now, an increase by 50% to both the height and the width means that the area of the next frame is going to increase by 9/4. Because if frame 1 has width 1 by height 1, that tells us frame 2 is going to be 1.5 or 3/2 of width 1 by 3/2 of height 1. So therefore, the common ratio here is going to be 9/4. So therefore, the area of frame sub n is going to be equal to the area of the first frame, which is 20, multiplied by the common ratio, which is 9/4. And this is going to be raised to the power of n minus 1. And this here is just the geometric sequence formula. And then our units here would be centimeters squared. And that is exactly what we're trying to show. Now, the second part of this question is asking us to find the mean area of the 10 picture frames. And we want to give our answer in this particular form, where P is a quotient and A is an integer, both which are positive numbers. So now we know that the mean is going to be equal to the sum of the areas divided by the number of frames. So that means it's going to be S sub 10 divided by 10 because we have a total of 10 frames. So using our geometric series formula, we have S sub 10 is going to be equal to the area of the first frame, which is 20, multiplied by r to the power of n, so that's 9/4 to the power of 10, minus 1, divided by r minus 1. So 9/4 minus 1. And then here we can be a little bit smarter. We don't want to do any unnecessary work. So the form that we want is p times 9/4 to the power of a minus 1. So notice that here we already have 9/4 to the power of 10 minus 1, which tells us that we kind of want to just leave that as it is. We don't want to expand it out. But we do want to simplify this portion of the expression. So we get this is equal to 20 times 9/4 to the power of 10 minus 1 over, and 9/4 minus 1 is just 5/4. And now we can go ahead and simplify this into 16 times 9/4 to the power of 10 minus 1. And then finally, we can take this and substitute it back into our mean equation. So which means the mean here is going to be equal to 16/10, which simplifies to 8/5, times 9/4 to the power of 10 minus 1. And now this is in the form that we want. So here our P is equal to 8/5 and our A is equal to 10. And the last part of this question is asking us to find the median area of the 10 picture frames. And again, we're asked to provide our answer in a particular form. So now since there are 10 picture frames, the median is going to be the value that sits between area of the fifth frame, and area of the sixth frame. So meaning our median is going to be equal to the area of frame 5 plus the area of frame 6 divided by 2. So now we just need to go ahead and find the area of these two frames. The area of the fifth frame is going to be equal to area of the first frame times the common ratio raised to the power of 5 minus 1. So this is equal to 20 times 9 over 4 to the power of 4. And the area of frame 6 is going to be 20 times 9 over 4 to the power of 5. So this means the median is going to be 20 times 9 over 4 to the power of 4 plus 20 times 9 over 4 to the power of 5 divided by 2. And this can be simplified to 10 times 9 over 4 to the power of 4 plus 10 times 9 over 4 to the power of 5. So now we can see that the form that we want has a 9 over 4 to the power of 4. And from our current expression, we can factor 9 over 4 to the power of 4 from both terms. So we get this is 9 over 4 to the power of 4 multiplied by 10 plus 10 times 9 over 4. So we get this is equal to 130 over 4 times 9 over 4 to the power of 4. And let's just go ahead and simplify our fraction in front. So our final answer here is 65 over 2 times 9 over 4 to the power of 4. And that's in the form that they asked for. So this is our final answer. And now let's take a look at our next question. Again, you can pause the video if you need time to read and digest the question. Once you're ready, let's dive in. First, we're going to consider the case where the series is geometric, and we want to show that p is equal to positive or negative 1 over root 3. So if the series is geometric, then that means we can go ahead and take the second term divided by the first term, and that's going to be our common ratio r. So that means we would have r is equal to p times ln of x divided by ln of x. And this simplifies to p. But we also know that if we take the third term and divide it by the second term, that's also the common ratio r. So which means r is also equal to 1 over 3 times ln of x over p times ln of x. And this is equal to 1 over 3p. So now we have two different expressions for r, and we can set them equal to each other, which means we get p is equal to 1 over 3p. Multiplying both sides by 3p gives us 3p squared is equal to 1, which means p squared is equal to 1 over 3. And now we can square root both sides, which means p is equal to positive or negative square root of 1 over 3. And of course, we can rewrite that as positive or negative 1 over root 3. And thus, we have shown what we needed to show. Now for the next part, it says, given that p is greater than 0 and the infinite sum is equal to 3 plus root 3, we want to find the value of x. So since p is greater than 0, then that means we're only taking the positive square root. So that means p is equal to positive 1 over root 3. And now from part 1, we saw that the common ratio r is equal to p. So therefore, we know r is equal to 1 over root 3. So therefore, our infinite sum, s sub infinity, that's going to be equal to the first term, so u sub 1, over 1 minus r. Substituting in the values that we know, we end up with 3 plus root 3 is equal to ln of x over 1 minus 1 over root 3. And now we can go ahead and multiply both sides by 1 minus 1 over root 3. So we get 3 plus root 3 times 1 minus 1 over root 3 is equal to ln of x. And now we can just distribute the left-hand side, and we get 3 minus 3 over root 3, and 3 over root 3 is just root 3. And then we have plus root 3 minus root 3 over root 3, which is 1. And this is equal to ln of x. The middle terms will cancel, and we get 2 is equal to ln of x, which means x is equal to e to the power of 2. And now for the next part, we're going to consider the case where the series is arithmetic with a common difference d. So now we want to show if that's the case, then p is equal to 2 over 3. So we're going to start the same way. The common difference d must be equal to the second term minus the first term. So that'll be p ln of x minus ln of x. And we can factor out an ln of x, which means we get ln of x times p minus 1. But we know that the common difference must also be equal to the third term minus the second term. So this is equal to 1 over 3 times ln of x minus p times ln of x. And again, we can factor out the ln of x, and that's times 1 over 3 minus p. So now since we have two different expressions for the common difference d, we can set them equal to each other. That means we get ln of x times p minus 1 is equal to ln of x times 1/3 minus p. Dividing both sides by ln of x to cancel it out will give us p minus 1 is equal to 1 over 3 minus p. And just a quick note, we can divide both sides by ln of x because we're told that x is greater than 1, which means ln of x cannot be equal to 0. And now solving for p is going to give us p is equal to 2 over 3, which is exactly what we wanted to show. Now the next part is asking us to write down the common difference d in the form of k times ln of x, where k is some quotient. So we can pick either one of these two equations and solve for d. And the first one looks a little bit simpler, so that's the one that we're going to go with. So we get d is equal to ln of x times p minus 1, so that'll be 2 over 3 minus 1, which means d is equal to negative 1/3 times ln of x. And this is in the form that we want, with k being equal to negative 1 over 3. And now finally, the last part of this question says that if the sum of the first n terms of the series is negative 3 ln of x, what is the value of n? So that means we know s sub n is equal to negative 3 times ln of x. We know that our first term, u sub 1, is equal to ln of x. And we know that our common difference d is negative 1 over 3 times ln of x. Substituting these values into the arithmetic series equation is going to give us negative 3 times ln of x is equal to n divided by 2 times 2 times ln of x plus n minus 1 times negative 1/3 ln of x. Notice that we can factor a ln of x from both of these terms and then cancel it out with the left side. And again, we can do that because we know x is greater than 1, which means ln of x does not equal 0. So that simplifies to negative 3 is equal to n over 2 times 2 plus n minus 1 times negative 1/3. And now we're just going to expand out the right-hand side. So we get negative 3 is equal to n plus 1 over 6n minus 1 over 6n squared. And now we're just going to multiply this entire equation by negative 6 and move everything to one side. So we get 0 is equal to n squared minus 7n minus 18. And here, this gets factored into n minus 9 and n plus 2. So that means the two values for n are going to be n is equal to 9 or n is equal to negative 2. But since the number of terms must be a positive integer, n equals -2 is not a valid solution. So therefore, our answer here is n is equal to 9. And now the last question of this video actually comes from the 2015 Fermat Contest. So here we're given that A, B, C satisfies the following condition. First of all, A, B, and C are 3 distinct integers, and they form an arithmetic sequence in that order. And when you multiply them all together, you get 17,955. And also, this here forms a geometric sequence. So what is the value of A plus B plus C? So first of all, because A, B, and C are 3 distinct integers, we know that the common difference must not be equal to 0, or else all 3 integers will be identical. Next, we're going to use the trick that we saw in a previous video, which is using symmetry. So since we have 3 terms in the sequence, A, B, and C, we're going to rewrite the terms in terms of the middle term and the common difference D, meaning A is going to be equal to B minus the common difference D, and C is going to be equal to B plus the common difference D. Next, we're going to use the third bullet point, which says that these expressions here form a geometric sequence. So that means if we take the second term, which is 3b plus c, and we divide it by the first term, which is 3a plus b, this must be equal to the third term, which is 3c plus a, divided by the second term. Next, we're going to cross multiply, so we get 3b plus c squared is equal to 3c plus a times 3a plus b. Next, we're going to substitute these expressions for a and c into our equation here. So 3b plus c is going to be 4b plus d. So we get this is 4b plus d squared. And this is equal to 3c plus a becomes 4b plus 2d. And 3a plus b turns into 4b minus 3d. And now expanding out both sides will give us 16b squared plus 8bd plus d squared is equal to 16b squared minus 4bd minus 6d squared. Now we can cancel out the 16b squared on both sides, and we get 12bd is equal to negative 7d squared. And since we've already established that a, b, c being 3 distinct integers means that d can't be 0, means we can divide d on both sides. And this simplifies to 12b is equal to negative 7d, which means we can now have our d as an expression of b. And we get d is equal to negative 12 over 7 times b. So now we can go ahead and express a and c in terms of b only. So we get a is equal to b minus, and d is negative 12 over 7b, which means a is equal to 19 over 7b. And then we have c is equal to b plus negative 12 over 7b. So therefore, c is equal to negative 5 over 7 times b. And since now we have everything in terms of b, we can substitute this into our first bullet point, which says a times b times c is equal to 17,955. So that means we get 19 over 7 times b. So that's our a, times b, times c, which is negative 5 over 7b. This is equal to 17,955. So that means we get negative 95 over 49 times b cubed is equal to 17,955. Isolating b cubed gives us b cubed is equal to 17,955 times negative 49 over 95. And the right side evaluates to negative 9,261, which happens to be a perfect cube, so b is equal to negative 21. So now that we have the b value, we can go back and find our a and our c so that we can calculate the value of a plus b plus c. So the last step here is going to be a plus b plus c is equal to 19 over 7 times negative 21 plus negative 21 plus negative 5 over 7 times negative 21. And this is equal to negative 21 times 21 over 7, which means our final answer here is going to be negative 63. And now let's do a quick recap of what we covered in this video. Again, we saw the trick of using symmetry to our advantage. When handed a symmetric sequence of odd-numbered terms, like ABC, you want to anchor your variables around the central term, so that makes your calculation easier. We saw that when your sequence variables are algebraic expressions, you want to use the definition of the common difference or the common ratio to set up your equations. So things like setting u sub 3 minus u sub 2 is equal to u sub 2 minus u sub 1 for arithmetic sequences, or u sub 2 divided by u sub 1 is equal to u sub 3 divided by u sub 2 for geometric sequences will be the fastest way to crack the algebra. And lastly, consider the dimension that you're working in, because linear scale factors don't translate directly to area or volume. Because if the side length of a geometric shape grows by a multiplier of k, then the area is going to grow by a factor of k squared, and the volume is going to grow by a factor of k cubed. So make sure you double check that first before jumping into your sequences and series formula. And now it is your turn to give this a try. Can you find the solution to the problem on the screen here? Make sure to leave your answer in the comments below and let us know what other sequences and series topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.